Here's part 2 of the 2.03 review, the dissolving process. Many factors influence the dissolving process. Knowing these factors allows chemists to prepare solutions effectively. Many solutions are prepared by dissolving a solid in a liquid. Dissolution, or the dissolving process, occurs as a result of random molecular motion. The particles and matters are in constant random motion. Over time, these random motions cause the solute and the solvent to become evenly mixed. Intermolecular forces, or the forces that are between molecules, like if I had two water molecules, there's the hydrogen bonding force between them that keeps them near each other. Intermolecular forces can also cause dissolution. Anything that increases the motion of the solute and solvent in particles, or increases the number of solute particles exposed to the solvent particles, increases the rate of dissolving or dissolution and the amount of solute that can dissolve in a given amount of solvent. Therefore, heating a solution, stirring a solution, or breaking a solid solute into smaller pieces so it has more surface area can all increase the rate or the speed at which the solute dissolves. Heating the solution also increases the solubility of the solute or how much can be dissolved. The solubility of a solute is the maximum amount of solute that can dissolve in the given amount of a solvent at a given temperature. So our objectives: describe how dissolution occurs, define solubility and explain how it's measured, describe the factors that affect solubility and the dissolving rate. Remember, solubility. A solubility curve is a graph that shows the effect of varying temperatures on the amount of solute that can dissolve in a given amount of solvent. The solubility of a substance is the amount of substance that can dissolve in a given amount of solvent. Solubility is generally expressed in units of grams of solute per 100 grams of solvent. So grams of solute divided by grams of solvent. Interpret a solubility curve. So first of all, look at our axes. We have temperature and we have solubility. So the amount of grams that are in 100 grams of water. And look at your pattern or your trend. You can see that as the temperature goes up, so does the solubility, and then whoa, it really jumps up after about 65 degrees. It really jumps up. A student performed a laboratory experiment to create a solubility curve for solid potassium nitrate, or KNO3. A solubility curve shows the mass of a solute that can dissolve in a solvent at different temperatures. So in other words, they took some water at 30 degrees and they saw how much could dissolve. They took water at 40 degrees and they saw how much could dissolve. They took water at 70 degrees and they saw how much of the KNO3 could dissolve. Use the student's graph of temperature versus solubility shown below to determine the number of grams of potassium nitrate that can dissolve in 100 grams of water at 50 degrees Celsius. So at 50 degrees, how much can dissolve? Looks like right around 80 grams. Okay, and so they show you here, they go up to the best fit line and they go over and they said, oh, it's a little higher, so it's about 85 grams. Okay, so here are our three questions. Copper 2 sulfate, or CuSO4, is a bluish solid at room temperature. A student adds some copper 2 sulfate to water. Describe two ways a student could get the copper 2 sulfate to dissolve more quickly. So hit pause, write down your answers. Question 2, explain how the graph in example 1 shows that increasing temperature increases the solubility of a solid in water. And so we'll back up here so you can see that graph again. Go ahead and hit pause and get your answer. And 3, explain the difference between solubility and dissolving rate. So again, hit pause and write down your answer. Okay, so the answers, question 1 says, describe how you could get your copper 2 sulfate to dissolve more quickly. You could stir it and you could heat the solution. The other thing that you could also put is, instead of having one big chunk, you could have lots of little chunks so you had more surface area. Question 2, how does the graph that shows increasing temperature increases the solubility of solid in water? The graph curves upward, or it has a positive slope. At higher temperatures, more potassium nitrate dissolves in the water. The solubility of a solid is the amount of solid that will dissolve in a given amount of solvent. Increasing the temperature increases the amount of KNO3 that can dissolve in 100 grams of water. So increasing the temperature increases the solubility. If this was a lab question, I would ask for data. And so what you would tell me is you would say at 40 degrees, only about 65 grams can dissolve, whereas at 80 degrees, almost 160 can dissolve. And our last question, explain the difference between solubility and dissolving rate. The solubility of a substance is the amount of the substance that will dissolve in the given amount of solvent at a given temperature. The dissolving rate of a substance is the speed at which the substance mixes with the solvent to form the solution. Okay, and that's it for your review. If you didn't feel like you knew all these answers, please go back, watch this again, watch the other recordings, and check your notes. And as always, if you have questions, let me know.